Here we have the ZM-100. This is the final rendition, the final version that we were able to come to. It has an extruded aluminum case. It had a slip-on cover that caught the bottom of the case, and you have to put both end panels on to trap the cover. Everything's either mounted on this board here, the extrusion, and this one switch is mounted on the front cover, or the front faceplate, which is a problem. What we have here for the SWR circuit is just basically the old not the Heath kit. Very similar. It's similar to the Heath kit, or it's similar to the design that's in the old handbook. So it's real simple. The advantages of this particular circuit is it requires no power if you can get a hold of a milliammeter or a microammeter. It's a microammeter, and that's the problem. The power requirements are so low, these things are almost impossible to get anymore. So that's a problem. The goal was to make the unit not require any external power. That may not be practical. So the advantages are the same advantages as with the ZM-2. The tuning is sharp. It tunes just about anything. Like I said, the disadvantage is the way this is made. You have to basically mount this, and then it's difficult because of the way this is mounted. So either there needs to be an additional mount bracket here to mount both the meter and the switch here, or a different arrangement needs to be done altogether. So this is the one version. The other concern is that this toroid would get loaded and not handle, it would overheat and not be effective. So other than that, the circuit's very similar to the ZM-2. We had silkscreen faceplates, actually silkscreen and CNC'd faceplates, so that the locations were accurate. Actually, the base is CNC'd too. The holes were drilled. We did a numbered run. So this is pre-release 1. This is number 10. So it was all CNC'd. Both of these capacitors are vernier. So if you look at the capacitor, you see the ball bearings in here. The inner shaft turns faster than the outer shaft. You can see the knobs turning a lot more than the outer shaft. So because the ZM-2 is so sharp, sometimes your tuning is just right there. I mean, that's what you need. And one of the other disadvantages I'm concerned about, I don't have all the test equipment. One of the other concerns I had was the proximity of this capacitor. This one isn't as bad, but this capacitor, the proximity to the top of the enclosure. The enclosure sits right on top of this lip, and if you look down there, there's about a 1/4 inch clearance. I was concerned that the tuning might not be linear because of the enclosure. That was one of my concerns. So, like I said, the circuit is basically a ZM-2. It's just beefed up with the air variable capacitors instead of the polycaps. Like I said, we have face plates. We did all that work, and both kinds of the front and the back. This is middle of production. This was its earlier stage here. I did a bar graph display, and it basically worked, but the thing I don't like is it requires power. So I guess an option would be to mount a battery right here externally, and then it wouldn't be such a big deal, and we could run a chip and a bar graph, or a milliammeter here instead of a bar graph. I personally do like a needle better. It's just easier to tune with a needle than it is with LED. This is, this worked. This is basically the same layout as in this chassis. We just had to move the switch up. Mounted these on the bottom instead of on this plate. So that's where we're at.